at Trondheim University. He's working with Curtis Whitson up there on layered no-crossflow reservoir behavior. And he'd requested the opportunity to come down here, attend this class, because some of this stuff I haven't had a chance to lecture on up there. And also, he has put together a good set of notes on rate time equation summary that we're going to make copies of and distribute to the people in the class here. So, and apparently some of you people already know him because he's originally a native of Stavanger here. And this trip is kind of combination learning and a little bit of vacation for him and his family. Yesterday, we talked about rate time, and I was trying to introduce at various stages some of the ideas of layered no-crossflow reservoir behavior. And you mentioned earlier that this stuff kind of developed out of work we did on a panhandle area, a shallow reservoir like the Red Cave is only 1,800 feet deep. The shut-in pressure is around 450 pounds, and next we got exposed to it by going down into the brown dolomite in the Oklahoma-Hugoton and the work that was done in Kansas, and we also saw data in the West Panhandle. And it appears to be everywhere. But a lot of people, when I make the presentation, particularly I gave a presentation in Odessa SPE, everybody, you could tell by just reading their faces, what does this have to do with us? That's, the Guyman-Hugoton. And trying to give you the idea that it is universal when you start knowing what to look for. One of the rules, or a rule of thumb that we had used, I mentioned earlier, is reservoir, if it's thick, is definitely going to have layered no-crossflow reservoir behavior. And in fact, this is true. Interesting part, there's a fella that works for Phillips now that was with Occidental, originally City Service, Occidental in Tulsa. And he'd spent his whole career in enhanced recovery, water flooding and EOR. And it was very, very interesting in visiting with him about that he had a rule of thumb that he developed looking at enhanced recovery projects. Again, this isn't just primary. The thicker the reservoir, the higher the B value was on the ARP's exponential decline. This is a totally independent source and a totally different discipline also, enhanced recovery. I'll show you one of his overheads here. In a little bit, but I want to also get, here's an example that a reservoir problem that came to us from the Borger office. Dave Reese works for me, and he took a look at it and looked at the performance, and there's a rate time plot. It's the wall lease. It's in the Morrow, which is about 9,000 feet deep in the Anadarko Basin. So it isn't an 1,800 foot or a 3,000 foot low pressure well. This is the shut-in pressure on these wells is over 2,000 pounds. We'll see that in a little bit. There's a rate time plot. You look at it and you wonder whether that's low permeability or not. And then when he sort of dug into it, he found this well's only got 9 feet of pay. So, well, an example which you'll see in the literature, because there's a whole group out there working with the Bureau of Economic Geology at the University of Texas. They're geologists. And the reservoir engineers, or petroleum engineers at the University of Texas don't agree with the work they're doing either. But what they're trying to propose, and it's affecting government policy, because there's a fellow there that has a lot of influence in Washington, a bunch of geologists, that there's all kinds of reserves in the United States. All we have to do is infill drill. In the basic model that they have proposed, or they're proposing, is one where you have a well here, a region here, and then out here in some way you've got, there's a barrier here, and then you have another permeability region here. And sure enough, you can take this type of model, and you can exactly get this type of rate time behavior, and you can exactly get the P over Z coming down, and so on and so forth. But one of the problems is this was the model they proposed in Kansas to justify infill drilling in Kansas, is they've drilled over 1,500 wells. They have yet to find a region like this that is at high pressure. It just doesn't exist. And this is what the one group at the Bureau of Economic Geology is proposing as a cure to all our energy yields in the States, that we could double our reserves in gas and oil by doing infill drilling. And they totally ignore all the work that's been done and published in terms of layered no cross-flow reservoirs. And there's a paper that you're going to get a copy of a fellow did some work on a gas well that shows this type of behavior on the rate time and the P over Z and so on and so forth. And he looked at water influx, the composite reservoir. That's what this is called, the composite reservoir. And layered no crossflow. And the final conclusion after he did all his work was layered no crossflow. And the way you answer the question is you go in there, we mentioned the other day, this is going to be the well bore, is you go in there and you take RFT pressures, okay? Well, the Borger office utilized this technology to improve a lot of their production out there. And their management actually backed them up in spending the money to take the data. So they ran an RFT on this, this well. But let me show you a little more first before I get to that. You already know where we're going to end up, but this is the P over Z. And Dave Reese said, well, this is a classic example because it's so thin that it's got to be a composite reservoir. Okay? That's the P over Z. Remember the rate time, and when you plot the rate time log, there isn't any transient in the data. It's all a very high B value. To get back to the final point, the RFT data, there's a 100-pound difference between the top and bottom of the pay. Now he's only 9 foot thick in the upper 1 foot interval. You know, so you don't completely limit yourself to the idea because it's thin that it can exist. And they repeated the RFT test, and they got the same answer the second time. There is a differential depletion in this, and this is a marl. Yeah, basically a dirty sand. It isn't a carbonate, and it's deep, high pressure. Well, you can see from the P over Z, roughly it's over 2,000 pounds, the initial pressure. You know, so I just want to kind of try and get used to the idea that it's what I'm going to show you predominantly today is going to be the work that we did on the Red K, which is low pressure, shallow, 1,800 feet, and the Oklahoma Hugoton, which is also about 3,000 feet in low pressure. But don't dismiss it because you're in Norway. You're going to have a portion of these overheads. You're not going to have all of them because I've expanded. I normally give a presentation in one day of a combination of rate time plus the layered no cross-flow reservoir behavior. Let me show you the other one that I mentioned to you about the fellow that works for, or used to work for Oxy, before I cover this up. I mentioned this to you the other day, and he was able to confirm by history matching this area and then running the model for sure, because he had other data. And I think he even had some of the primary performance data of a project in West Texas CO2 project. This is the water flood, your period water flood behavior. This is the CO2 forecast. And this would be the difference in attributing enhanced recovery by just drawing exponential decline, or the B value he determined from his work is 0.65. Okay? Big difference. In what people are normally doing when they're using exponential and evaluating enhanced recovery is they're just getting they're attributing a lot more recovery to the process than actually it deserves. Okay? And when you go into the theory of what should be recovered from the CO2 with the basic analytic equation and laboratory work and so on and so forth, this number, the cumulative under the area of this curve, is a very reasonable number with regard to what should be attributed to it. But you can see that this custom of using exponential to do all your forecasting in the future, particularly with regard to enhanced recovery, is going to lead you astray about how much that you're really getting there. You know, is it really economical? I'll show you that again later. And this, well, before we get into it, I might as well get into this aspect. Yeah, this is what we're talking about, okay? Layered no cross-flow reservoir behavior, where, you know, this would be the high perm layer, this would be the low perm layer. And you could take these flow equations, make forecasts, add them together, and you're going to get a composite effect. This is no different than this problem here, okay? It's exactly the same problem if you have a regional variation in properties. We talked about this before. And this should be easier to see for gas, you know, because this is going to be the pipeline, this is going to be the wellhead pressure, and I'm going to have the same flowing pressure against both of these regions, just like you would at the bottom of a wellbore. So you take all the concepts of a layered no crossflow and you can turn it over, you know, just turn the diagram over, and it's a regional problem too. But if I go in here and I take pressures in this region and this region here, now I know that they're if the pressures would be dropping differently. I can recognize that. But when I have this type system and I shut the well in and I take a pressure, I just get the pressure of this one here. I don't have a clue what this one is here. You say, well, I can go back into these wells. We tried in the Texas Hugoton and Oklahoma Hugoton to go back into some of the old wells and you set bridge plugs, try and get it, but all the wells were acid fracked. So what we did was we fracked and broke down the seal between the barrier between the layers such that it was backflowing okay, but it was out in this region and we couldn't detect it in the wellbore. You know, so that if you're looking for this type of data in a reservoir and you drill a replacement well or an infill well or something like that, you have to plan ahead to try and get that information before you break down any type of barriers. And I think we've seen the barriers as thin as just a few inches could be total seals. You know, it really don't have to be very thick. So this is just trying to get you to look at things in this direction. And that's the model that the Bureau of Economic Geology is peddling, and also the people in Kansas that were trying to justify infill drilling was peddling. Exactly the same problem. Okay, here's some type of invisible, impermeable membrane, and here's volume 2, volume 1, and with that, again, you can get these identical types of behavior. One of the problems when you, I think I mentioned the other day, when you come down into Oklahoma, what they're originally proposing in Kansas is let's drill an infill well in the northwest quarter. You know, so we're going to get all these reserves. They showed that they could practically double the reserves with their one well simulation models. And this is the type of barriers that they built. And then royalty owners in Oklahoma said, heck, if you can double the reserves by drilling in the northwest quarter, let's drill in the northeast, the southwest, and southeast quarter. Let's drill 4 instead of just 1. You know, so we were kind of in the box of, well, we better get busy on this, or we're going to lose our acreage, because you go through the evaluation, and it's not economical to do infill drilling. And in some of their papers of the Bureau of Economic Geology, they're also, this is how they're proving by taking performance data on fields and say, look, with our model and that support, this is all the extra reserves that's out there. But of course, they're using exponential decline and attributing all of this to this gas migrating out somewhere from these barrier regions. You're going to get a copy of, they were giving a seminar in Houston, I think a 1 or 2 day seminar to the industry. Hey, you double your reserves, come attend our seminar. And a lot of people went, and I sent Dave Reese, to try and at least see what they're saying. He brought back a bunch of material. There's a copy of a trip report in there when he went down there to that presentation. But this is very simply, naturally, a b-value that's not exponential, and very easily is a layered no-cross flow system. In fact, at one of the presentations they gave at an Archie conference, I asked, did you ever get any pressures in some of the layers? Oh yeah, they're 2,000 pounds, and the original was about, around 2,500. He never recognized that pressure in that layer had nothing to do with their the type of model that they were proposing. That it just actually verified the layered no-cross flow reservoir behavior. So the impact is pretty great because this guy has a lot of influence. Like I said, in Washington, we're trying to convince the government that we can double our reserve just by infill drilling. Now, oil or gas anywhere in the United States. So this is why we took the trouble. Whitmire requested that we document the work that we did on the studies in the Oklahoma Hugoton, and there's 5 papers that we published on the subject. 3 of them were given at the SPE meeting, but all 5 were included in the proceedings. In the back of your book, you've got copies of all 5. It was interesting when I gave my paper on the model work that you got comments from some people in the industry that said, I thought you hated models. Because I did the model study. I really don't. It's just I don't like the misuse of models. And that's what 3 major companies did with the work that they did up there in Kansas to convince the commission there was all of this additional reserves available just by infill drilling. They all did basically one-well model studies. Mobil did a multi-well, but all they tried to match was the P over Z. They didn't match layer pressures or they didn't match deliverability. Now, after our work, they're up there now fighting again the case where Oxy, who was the initiator of the whole thing, wants to be subsidized because their infill wells are not economical. They want they want an extra allowable now on those wells that they drilled that aren't economical. So we're starting all over again up there in Kansas. We're assisting the best we can. Mobil has used our exact approach in order to do the study, revise their work, and they're getting exactly the same results that we're getting, or that we published in our paper. So the fact we got it out, or the objective of getting it out, was that if anybody was going to do any more studies, we hoped that they would, or that we'd show them the procedure they should be using to do a correct study. Because if they did, everybody had come to the same conclusion. And I've heard from out in the Texas Hugoton West Panhandle area where some operators were proposing to do some infill drilling there, and our lawyers were able to kind of convince them that we're going to fight you as a result of the work that we've done in the Oklahoma Hugoton.